Welcome to the Structured Cabling lecture series. This is lesson number 5 and I will cover optical fiber. If you haven't seen my previous lectures, I will post a link in the description for the playlist. In this lecture, I'm going to go over some concepts related to optical fiber, also known as fiber optics. So if you look at the history, as old as 1840s, the research on fiber optics have been done by various scientists and researchers. In the 1940s, foundations on how light reflects and refracts was put into physics and mathematics areas of research as a fundamental concept, and it was further developed over the years. So when we are tracing back how the optical fiber research has been started, we have to trace back to those fundamental years of 1840s, because that's where when we first beginning to understand how light reflects and refracts and how we can use it to our advantage. In the 1953, Dutch scientists first demonstrate the image transmission through bundle of optical fibers with a transparent cladding. What they were able to do is basically to transmit an image like with some kind of a visual representation through a bundle of optical fibers from a distance away from the position of the image. So basically you have an image in the laboratory and you have a bundle of optical fibers, and on the other end of that bundle you can weave that image. So in 1953, this particular research basically laid the foundation for what we call the modern day fiber optics communication. And two other scientists later in the Imperial College of London succeeded in making image transmission bundles with over 10,000 fibers as opposed to a couple of fibers in a bundle in the 1953. In the college, the Imperial College of London, they were able to use 10,000 fibers and then transmit similar data across the system. So basically using an image on the one end and weave it on the other end using 10,000 fibers. And as a result, subsequently, we achieve image transmission through a 75 centimeter long bundle, which combines several thousand fibers. So this is a huge step for the modern day optical fiber or fiber optics communication systems. Then a scientist called Kapney coined the term fiber optics after writing a 1960 article in Scientific American that introduced the topic to a wide audience. So he subsequently wrote the first book about this particular field called the fiber optics. So in 1960s is basically where the fibers start to become a viable option for data communication. I'm going to give you a brief description of why we have these two terms. So the fiber optics and optical fiber, they basically in most parts of the world describe the same thing. However, because of this 1960 paper that was written in Scientific American, when we discussing anything to do with communication mediums such as data transmission, packet switching, internet networks, we typically refer them as fiber optics communication or fiber optics cables. When we are discussing anything to do with laboratory conditions, we typically refer to them as optical fiber. So it's kind of confusing, but they are interchangeable words in my opinion, depending on who you are talking to. So you will meet structured cabling engineers and optical fiber optics engineers that they interchangeably use the fiber optics and optical fiber, these two terms. But in general, in North America, like in Canada and United States, for example, we typically use fiber optics or fiber optics engineering or fiber optics cabling when we are discussing anything to do with the data transmission and cabling, and we use optical fiber when we are discussing the actual research going into this one of these cables, like in a very micro level research. But at the end of the day, honestly, like I said, it doesn't matter whether you use optical fiber or fiber optics. But you really need to understand in 1953, when they were doing research, and even in the 1840s, we used to use the term called optical fiber. And when in 1960, when Scientific American published this research from this scientists, we start using the term fiber optics communication. So keep that in mind. Fiber optic communication, which was first developed in the 1970s, even though the research paper was published about a decade before. And in 1970s, this development by researchers all over the world, not only in United States, but also in Japan, for example, NEC, the Nippon Electronic Council, a bunch of other organizations, NTT from Japan as well, did research on this. In 1970s, it became a viable option for data communication. So we could look at 1970s as a turning point in telecommunication industry and information age. What is information age? Information age is basically describe a period in technology development where we went from using telephony systems, basic PSTN telecommunication systems, which you have a cable, metal cable like a copper cable, with exchange systems where you can pick up a phone and dial a number and call someone, to a point where we turning into an information age where we are using these cables to transmit actual packets with data in it. So that's what we mean by information age. I'm not going to go into detail on history of information age and how we can break down information age, but just know that the fiber optics communication become a viable option around 1960s with the 1950s and 60s with the publication of those research papers, but it actually become a real world application viable option in 1970s as a result of these developments into this particular field. And this actually helped build the backbone networks all over the world. So what are backbone networks? I have already described what they are in my previous lectures, but if you don't remember, recall the backbone networks are networks that are connecting data centers, connecting different countries, different cities. So large scale infrastructure that provide intercommunication is what we call backbone networks. In the early stage of information age, the backbone networks are typically used to connect research institutions, for example, universities with other universities, or different buildings within the universities are interconnected using these backbone networks. So again, in the early stage, they use the copper cables, but with the development of fiber optics or optical fiber communication in the 1970s, we move on to the using the fiber for connecting different countries, cities, etc., etc. It allows faster communication, secure communication, and much more bigger, better, faster bandwidth, for example, among different groups and countries. So that's why we use it. For example, majority of submarine cables that connected Japan to the rest of the world in the 1960s and 70s and 80s, which some of them which my dad actually used to work with. My dad is a optical fiber or fiber optics engineer. Basically connected the whole world with Japan with high-speed communication systems. So keep that in mind, that when I say backbone networks, I mean large-scale infrastructure networks. So why we use it? I already mentioned a few things. Low signal attenuation, almost no or extremely low interference. So there is no electromagnetic interference with fiber optic cables, optical fiber cable, and higher data speeds and bandwidth over long distances. So this is important to remember. The paper published in 1960 laid the groundwork and foundation for fiber optics communication. And in the 1970s, this fiber optic communication became a viable option for us to use in large scale network. And why we use it? Because it allows high bandwidth with these type of cables with low signal attenuation and almost next to nothing in interference, and it allow us to have high data speed and bandwidth over long distances. So cost associated with fiber optics communication cables are pretty high. So compared to a copper cable, even the highest grade copper cables are probably twice or even sometimes 3 times cheaper than fiber optic cables that we use today. So you need to understand that the reason why we use these cables because of the quality of data transmission, not because of the cost is really cheap. At least not the initial infrastructure cost as a structured cabling engineer that you're going to have to take into account. Fiber optic systems are therefore complex, expensive to install and maintain. So compared to a PSTN telecommunication network with copper cables or packet switch network with copper cables such as Cat5, Cat6 cables, fiber optics systems are always complex and always going to be a little bit more expensive to install and maintain. The cost of fabrication is also much higher than that of the copper cables. So if you are working with a cable manufacturer, the cable manufacturer quote for a fiber optic cable going to be always going to be higher than that of the Cat5e cables with the copper. If the manufacturer is making both types of cables, they will tell you that the cost is going to be much higher because the fabrication methodology is going into making those fiber optic cables is much more complex and more engineering mathematics intensive, the research intensive than that of the copper cable. And also the tolerances in which the fabrication of fiber optic cables are much more smaller compared to tolerances that you can take into manufacturing copper cables. So you could have copper cables that are a little bit slightly different from each other, but it'll still be meeting the standards of, let's say, Cat6. But to meet the standards of fiber optic communication cables, you need to have really low tolerances of manufacturing tolerances. So that's why another reason why it is really expensive. Installation also requires specialized tools to install, and those tools have certain considerations that you need to take into account, such as type of fiber optic cable and the grade of cables, etc., and the end connectors, for example, termination connectors also slightly differ from how you use those fiber optic cables. But with the increased use of bandwidth intensive applications in the information age, the benefits now actually shifting away from shifting downwards as opposed to the shifting upwards as opposed to the cost associated with it. So in other words, when you do cost benefit analysis, now benefits are much more higher, becoming more higher than that of the cost. And this is because of we are now in the age where we use a lot of video and music streaming. We do a lot of teleconferencing, and we use large-scale data centers as opposed to distributed data centers, which a small amount of users. We have more and more users globally connecting to our, packet switch networks. That means more and more people are connecting to the internet, and the site-to-site connections are becoming more and more important in this global information age. So as a result, we actually need fiber optic systems to handle all of this increasing bandwidth intensive application usage. So for example, about 30 years ago, not many people actually use video streaming or music streaming. Now, even you are watching this video maybe in 4K using YouTube, and the YouTube data centers use fiber optics. You can go and check out how Google manage YouTube, and all of their data centers are interconnected with mostly fiber optics. Wherever it is possible, the Google always use fiber optics for their YouTube data centers. And same with Amazon data centers, same with Microsoft data centers. They, because they need to support these high bandwidth applications such as video streaming, music streaming, and teleconferencing. So the cost associated with this kind of fiber optic infrastructure now actually below that of the benefits that we have. So benefit outweigh the cost at this point in 2022. So this is why in modern Canada that you can get connections to your home that is directly fiber to your home, because in the old days we didn't have it. Even 2 years ago in Canada, most houses only can have copper cable connection to their home, even with the gigabit network speeds. But now in 2022, majority of Canadian metropolitan and major cities have fiber to home connections that is available to them. So not everybody have it, but you can have it. So for example, in my house, I don't need the fiber to home. There's no need to purchase that kind of plan, but you can get that even in 2022 directly to your home. So basically you can have everything up to your house connected with fiber, and then you can wire your entire house with fiber as well if you choose to do so. So that shows that the costs have now gone down, and the benefits are becoming more and more important in installation of fiber optic mediums. So let's briefly go over fiber cable anatomy as far as a structured cabling specialist should be concerned about. There are slight variations on how specifications of fiber optic cables are in the market right now. So this is also true for copper cables as well. That's why we have things like Cat 5e, Cat 5, Cat 6 cables. There are different categories of variations of copper cables. The same thing can be seen with the fiber cables. Typically those variations are associated with the core diameter. So what a core in a fiber cable is, it's the center of the cable. That is where all the data communication happens, the packet switching happens. That's where the light, basically, in other words, photons are light energy that travels through. So the core diameter play a direct role in how well constructed your fiber cable. And the other thing is core and the jacket. That means the buffer and the outer materials of the cable. So for example, the fiber optic cables that you're going to be installing outside in, let's say, in a ditch is not going to be the same as the fiber optic cable that you will be using inside a building. So a lot of data centers, fiber optic cables will have that yellow jacket that you're familiar with, or a red, orange, or blue jackets. And those are basically a little bit flexible fiber optic cables. But if you're installing outside, for example, let's say you're doing direct burial cables, obviously they're going to have that specific jackets specifically designed to have that metal or Teflon cladding, for example, to allowing you to install the fiber cables directly in directly buried situation. So keep that in mind. I already covered these type of cable jackets in my previous lectures associated with direct burial cables of copper cables. So I'm not going to go into depth of that, but just remember, just like the copper cables, also seen in the copper cable, you see those kind of variation in the fiber cables as well. But addition to those, what really matters here is also there's something unique to fiber is the core diameter and the core, how the core is constructed. But fundamentally, the following components are what you need to remember when it's come to the point fiber cables or fiber optic communication. Those includes the outer jacket, as I mentioned, which is also seen in copper cables. Optional protection from physical damage, which is also you see with the copper cables, which are direct burial versus internal building use. Strength members, buffer, optical fiber or fiber optic stand, right? So what that means is basically strength members is basically what's around that core making that cable strong, so it won't break those glass fibers. So that's what I mean by the strength members. That could be Teflon, it could be metal fibers, etc., etc. And remember, fiber optic cables don't have electromagnetic interference, so we can use many different types of metal fibers to actually strengthen your cables depending on the manufacturer. And the buffer is basically there's a buffer around the cable, around the core, to protect it again from breakage and other things. And then finally the fiber optical fiber stand, that is the core itself. So next slide I will show you a diagram of that. So typically this is what the cable that you're going to get. Even the indoor use cables have most of these components. So we have the core, that's the most important part, which is typically made out of silica. And then you have the cladding right after it, which is also typically made out of silica, and combination of these two make the optical fiber itself. So if somebody in your exam or your professor or somebody asks you what actually make optical fiber, which is basically the core and the silica cladding. So the immediate cladding associated with the core, the combination of the two is what makes a optical fiber. Then we have the silicone coating, and then we will have the buffer jacket, and then we have the strength members, and finally we have the polystyrene outer jacket. But this polystyrene outer jacket may be made out of different materials depending on where this cable will be used. So if you are using in a networking closet, some kind of also like a server room, for example, this polystyrene outer jacket may not exist, just have the strength member and that's it maybe. And this can, it's not always black, it comes on yellow, blue, etc. It can have any color, but this is what a typical cable look like. So cables, majority of the thickness is not coming from the optical fiber, which includes the cladding as well as the core. It majority of it coming from the protection which the cable has. So keep that in mind. And also remember that this core and the cladding, even though it says silica is basically glass. So another way of thinking it is glass. So however, there are fiber cables you can take where the core is glass but the outer is plastic, and sometimes both of these two can be also plastic as well. So certain plastic materials, high grade plastic material, can be used for manufacturing fiber cables, so keep that in mind, even though commonly we use actually glass fibers. So typically the core is always going to be glass. So each optical fiber stand has 3 key components: the core, cladding and coating. Keep that in mind. And when you look at the optical fiber cable, there are 2 types, one called the multi-mode fiber and the other one called the single mode fiber, which I'm going to introduce in next few slides. And depending on what type of fiber, the core itself may be either very thick or very thin depending on your situation. So keep that in mind as well. Again, I will introduce what multi-mode and single mode means in the next few slides. Here's another image of a fiber cable that typically we use for outside environments that would have a little bit of strength added to the cable itself. So actual optical fibers are these, and then you will have the water resistant jelly, because this is an outside burial, direct burial fiber cable, and you will have steel wires around it, and then you will have a copper tubing, and then finally you will have a high density polystyrene insulation. See, again, in this situation, the actual data communication part where the packet gonna get switched in this direct burial cable is this tiny optical fibers, and everything else of this particular cable, the thickness of this particular cable that goes all the way to about 1.5 centimeters is basically the protection for these fibers. So the fibers itself is less than 2.3 millimeters, but the actual protection and everything put in together, the cable become 1.5 centimeters. So because of all these protections. So unlike copper cabling, we need all of these protections so that we won't break the cables. But this is what you need to understand, that actual communication where connection happening and the communication happening where photons, which is light energy, travel through the medium for packet switching and communication happen in these tiny less than 2.3 millimeter strands of fibers. So everything else that you see in these type of fiber cables are basically the protection associated with it. So what I'm telling you here is what you need to understand here before we move forward is that when you take a direct burial fiber cable, the majority of the thickness, more than 90% of the thickness coming from the protection, not from the actual communication cable itself. So I'm going to introduce a little bit about the family tree of optical fiber, systems. This is basically the fundamentals of how we break down the family tree, but I'm not going to go into depth of this family tree and how they are in depth of how they are different from each other, but I will go a brief overview on the next few slides. So basically I introduced in the previous slide something called the single mode and the multi-mode fibers. So we have a basically optical fiber as a structured cabling guy. You have the choice of selecting single mode fiber or multi-mode fiber. How do you pick from one or the other and recommend it? I will go through them a little bit in a brief description in the next few slides. But just remember, the fiber optic cable or optical fiber cable can be divided into two parts called the single mode and multi-mode. So that's the first division. The next division is that within the single mode, there are different grades of that cable. And you can see those grades up here. And then multi-mode, we also have two types called the step index and the graded index. And that's what you're going to get in that division. And then the next, what's going to happen in the multi-mode, the step index break into the plastic optical fiber and the plastic clad silica one. And then we're going to have the index, graded index. We have this OM2, OM3, OM1, OM5, etc. divisions. So do you need to know these divisions? If you are a junior level IT technicians and you are studying this course and that's why maybe you're on my YouTube channel watching this course, no, you don't. You don't need to know all of these breakdowns in detail. But if you are a senior engineer or you become a senior IT technician, eventually you need to understand these breakdowns and how they are differ from each other. In this particular course, I am not going to focus on all of these divisions and technical standard going into them in detail, because this is just a fundamental structured cabling course. In the future, I may post some video lectures where I go into depth of how these are different from each other and why they are important. And I may also post some live demonstration on how we work with optical fiber cabling or fiber optic cabling. But for now, what you really need to understand, there is a major two divisions. Those are single mode and the multi-mode. What are they? Well, I'm going to introduce you to that on the next slide. So here we're going to talk about types of fiber optic cables, which I have briefly introduced on my previous slide. So there are two main types of optical fiber used in optic communications. That includes the multi-mode optical fibers and the single mode optical fibers. So to briefly go over them, what you need to learn, what you need to understand as a junior IT technician, as a junior cable installer or a structured cabling technician, is that multi-mode optical fiber used for communication over short distances such as between nearby buildings, while the single mode optical fiber used for long distances such as the backbone infrastructure. The single mode optical fiber is used between countries, for example, between Japan and the rest of Asia, United States and the United Kingdom, like with the submarine cables, etc., as opposed to multi-mode fibers are what we use in short distances. If you are working in a network closet, if you are working inside a server room and you are connecting these different fiber cables, short fiber cables, you are most likely using multi-mode optical fiber as opposed to single mode optical fiber. Again, I will go into more depth of multi-mode versus single mode a little bit more in the next few slides, but not so much that it'll overwhelm you as a junior IT technician. Grades of fiber cables. So both single mode and multi-mode is offered in different grades. I basically copy this from Wikipedia. You don't need to memorize this for majority of the exams that you are going to take from academic institutions. But what you need to understand that both single and multi-mode fiber is offered in different grades. If you are taking engineering exams associated with fiber optics or optical fiber cabling, you need to understand fiber optics communications do have these grades and the nanometer of wavelength that we use in each one of them and all of these details, for example. But for general IT technician exams, and if you're in a technical schools and stuff like that, you don't need to know any of these things in detail. But remember that both single mode and multi-mode fibers are offered in different grades, and these are some of the grades that currently available in as of 2022. And here is a picture of a cable, fiber optic communication cable in a actual settings of like a installation setting. And here's what it actually looked like. This is a real cable that at what it looked like when you have communication going through. But keep in mind, not all light is visible, and not all visible light is used for fiber optics communication. That's why there are some safety concerns that you should take into account when you're working with cables that you believe is turned off. You should never look directly into these, for example. So I will go over that in the next few slides as well. Bend radius. So I have discussed bend radius in my previous lectures with associated with even copper cables. And I also have introduced bend radius and some of these concepts in this lecture in my previous lectures associated with other classes as well. So bend radius is basically how sharply a cable can safely bend without causing damage by creating micro cracks on the glass fibers when it comes to the point we are looking at fiber optics communication cables, because we have glass fibers in there, and there's so much a glass fibers can take, so much abuse a glass fibers can take until it start to break down its core material, right? So copper cables also has a maximum recommended bending radii. Radii is the plural term for radius, but they are less prone to damage. So depending on the type of copper cables, you may have a smaller bending radius or a larger bending radius, but you can bend a lot before it actually start breaking down and causing headache for you guys. And typically with copper cable, it's not the bending radius or bending radii that actually matter. What really matter is that if you have a situation where you keep bending and straightening, bending and straightening and bending and straightening and causing the copper cable to wear out. That's what the copper cables usually do. But however, when it's come to the point, fiber optics communication cables, well, they are more sensitive to bending. Therefore, the bend radius is super important in fiber optic communication cables. So how do I calculate bend radius? Well, the optical minimum bend radius is equal to 10 times the outer jacket diameter of that cable. That's a rule of thumb that we use in the industry. So if you are dealing with fiber cable that has a 2 millimeter outer jacket, then 2 millimeter multiplied by 10 give you 20 millimeter, and that 20 millimeter gonna be the bend radius. However, in my opinion, instead of calculating the bend radius of a really expensive fiber optic communication cable that your company probably purchased, instead of calculating using this rule of thumb of 2 millimeter outer jacket multiplied by 10, for example, you should just follow the cable manufacturer specifications. Forget about how we actually do this. Like, forget about the optical minimum bending radius is equal to 10 times the outer jacket of the diameter of the cable and doing all the calculations, etc. Just read the manufacturer specifications. There's a good reason why I'm telling you this. Optical fiber or fiber optic cables are really expensive. You do not want to be in a situation where you destroy bunch of cables or damage bunch of cables from your company because you are just calculating these numbers based on whatever the values you have. Instead, just follow the manufacturer's specifications and you should be good. But if for whatever the reasons you are in a class and your professor asks you, how do you typically, what is your rule of thumb for like calculating bending radius? That would be the bending radius is equal to 10 times the outer jacket diameter. So you take the outer jacket diameter, multiply by 10, and that will give you the bending radius. But in real world application, in real world scenarios, wherever you work, majority of companies expect you as a cable installer, as a structured cabling engineer to read the manufacturer's specifications. Read the damn manufacturer's specification. Don't try to be a superhero and start calculating bending radii. Instead of just read the manufacturer's specification for each cable type and each cable material. So that's what you need to do. So what would happen if you exceed the bend radius? If you exceed the bend radius, light may leak out, and more acute that you bend the radius. In other words, like if you make this bending radius really acute, that means you get a really tight wounding in here, right? You wound this around really tightly, more light leak going to happen. And the result of this going to be the data loss and degradation of performance, and this may result in even going the entire network out of service, or that particular line going out of service. So if you exceed the bend radius or of the manufacturer's recommended bend radius, you accidentally bend it too far, and then even after you straightening it out, it may result in the light leakage. That means you are losing photons. That means you may be losing packets, or even packet may not get switched at all. As a result, you will end up in data losses, degradation of performance, or out of service. So just because of a cable has exceeded that bend radius, you become really acute, going acute, doesn't mean you completely lose the connection. If you have a sudden loss in data speeds after installing a brand new cable, maybe you should check out if there is a damage there. And how the bend radius is calculated or measured is basically, this is the if you have a circular tube, and this turn can be calculated using that tube. So this is a simple mathematical calculation, and that will give you the bend radius calculation itself. Again, this is something to do with engineering side of cabling as opposed to technical side of cabling where you install, but I'm giving you this information. These are important things that you understand. And again, in this diagram on the bottom, it shows you have a fiber cable and you have the light, let's say a laser light that shine through. And when the radius become more and more acute, that leakage going to be more and more, that's going to leak more, right? Because light try to travel through straight lines, but however, we are just bending it the way we want it to travel through. But if you bend the cable itself more, then the light bending gonna have an impact on that. So this is showing that this is a bend radius, a wide bend radius, and when the bend radius become acute, that leakage gonna be much larger. So keep that in mind. What really important here is a lot of people don't realize you may not see these problems coming up as soon as you install the cable. However, it may come up over time, or it could be a result of just a simple small data losses and degradation of performance or speed, as opposed to completely the service going out of service, right? So keep that in mind. Fiber optic termination. So for termination, you must use the correct tools. That's really important that you use the correct tools, because sometimes some of these termination end connectors require specialized tool to terminate. Not all tools can terminate every one of these. For example, fiber optic capable other intermediary devices such as switches and routers also must be used when we are working with fiber optic cables. In other words, if you have fiber optic cables within a building, you need to make sure that your switches and routers within that building have the cable fiber optic connections so that those switches and routers can be used within the networks, right? You can use copper Cat5, Cat6 type switches and routers with fiber optics, in other words. Most commonly directly connected to servers and intermediary devices, but you can also direct connect other devices as long as the end device have the correct connection ports. So fiber optic cables are mostly used between fiber optic switches, fiber optic routers, fiber optic capable even servers, but you can use it on end devices such as a desktop computer as long as one of these connectors are available on the ports are available on your end device, and your fiber optic cable is terminated with one of these suitable connectors and they are compatible with each other. So keep that in mind as well. So let's look at the tools of the trade. Those includes the fiber fusion splicers, fiber fusion machines, fiber optic cutters and strippers, fiber optic cleaners, laser safety glasses, visual fault locators, inspection cameras, and tube cutters and knives are basically what should be in your toolbox. So for example, this is a fusion a machine. This is a fiber fusion machine, and these are really expensive, sometimes like $10,000, and you use this to put the cut two fiber cables together and fuse them together, for example, and you will need this type of equipment as shown here to work with it. And this is a Fluke company visual fault tolerant inspector. Again, you don't directly look into the fiber, you use these type of tools to check if the fiber is properly connected and there are no damages within the cable, for example. So these are some of the tools that you use that, again, I'm not going to go into detail of that, but you should know these tools exist. And I might do few demonstrations of these tools and how to use them in the future. But for now, just remember these tools exist. So this is a really important slide, even though it doesn't have much information, because I'm going to quickly give you the most important things that you need to remember working with fiber. You should never ever look into the fiber core ever when you work with fiber optics cables. It doesn't matter that your manager, your supervisor, your team leader, your senior people tells you that the cable is disconnected. You should never ever look into the cable. Even if your managers and supervisors tell you to look into it, do not do it, refuse it. It is illegal in Canada and the United States for any management personnel or team leaders or supervisors to ask you to look directly into the fiber cable, because it is a safety concern. Looking directly into the fiber optic cable could cause something called spot blindness or sarcoma. You probably heard about this from your optometric people, like the medical doctors. What it does actually, you will get blind spots in your back of your eye as a burning of your eye by those invisible light. Because remember, not only laser light can be used for transmitting data, we can use invisible light with the fiber optic cables as well. You don't see the light in that situation. So if you look into that cable, and you may not notice that the cable is turned on, but it could damage the back of your eye. And what is that going to do? It basically going to burn your the visual the things in your eye, and as a result, this might happen. So this type of situation could happen where you will have a permanent eye damage with the blind spots or in your back of your eye, and that cannot be repaired. You can't, there is no way to repair these things as of now in the healthcare field. So please, please, please never look into the fiber core. And doesn't matter whether the fiber, the optical fiber or fiber optic cable is disconnected, do not look into it. That's why we have tools. That's why we have tools like these things, which are visual fault locators, so that you don't have to use your own naked eye to look into the cable. Never do that. There is no reason to do it. Even if you look in and if you see the light coming through or not light coming through, what's the point? You can do fault tolerance by just looking at it. So don't look at it. And the other thing is glass fibers and your skin is another safety concern. That's why on the previous slide I mentioned that we have safety glasses. when you are working with fiber optic cables, you should always use safety glasses. Even if you're just simply laying a cable on the ground or simply plugging in a cable, I would recommend that you actually use the safety glasses. And for your skin protection, you can use these glass fiber rated gloves that will protect your hand. If you ever get those glass fibers inside your skin, you can use tweezers to try to get them out. And if you still feel there are maybe fibers inside, the glass fibers inside under your skin, you need to seek medical attention as soon as possible, because that could create medical complications down the road if you just leave that fiber inside your skin. So you need to take all of those into account. You need to be careful when you're working with fiber optics. You also need to read your equipment health and safety measures, which typically comes with the equipment itself. So if you buy an equipment that is used in the fiber optics cabling, read the manual, read the safety standard. If you have company mandated specialized safety training, pay attention to those safety training. Make sure that you go through them thoroughly before you go into the field. So I just want to give you a summary of fundamentals that I have covered in this lecture, and maybe give you a overall view of this lecture. So the fiber optic cables transmit signal and pulses of light over glass or plastic strands inside protective tubing. Today, I did not go over how we use packet switching to transmit those signals and pulses of light over that glass strand, but instead I primarily focus on the cabling side of things. Why? Because this lecture series is cabling, but you still need to understand the fiber optic cables transmit signals as pulses of light over glass or plastic strands, and most of the time we use glass, but sometimes we use plastic. They come in two types, which is called single mode and multi-mode. And I told you that the single mode uses a single path for light to travel through it, and the multi-mode cable use multiple paths to light to travel through it. Actually, I haven't introduced that concept in depth in the previous slide, but that's what the difference is basically in terms of how the light is transmission. Both single mode and multi-mode can be constructed as loose tube cables for outdoor use or tight buffered cables for indoor or outdoor use. So that's another thing you need to understand, fundamentals, which I haven't gone over in depth in previous slide, but you still need to know. And I also recommend that you watching my previous lectures on fiber optic medium on my other lecture series in that I have already posted on my YouTube channel. You can go ahead and check them out if you want to learn a little bit more. What is not covered in this lecture is basically the fundamentals of how fiber optic communication cables work. That's why I didn't cover about photons and reflection gradients and how we use those to send packets, switch data across a network, for example. So I didn't cover the physics and math behind it. I didn't cover the deep manufacturing concepts associated with fiber optic cables. I also didn't cover cutting edge, current state of the art research and innovation and future development of fiber cables. There's a reason for that. Is this lecture is already 40 minutes plus, so I just want to keep the lecture as short as possible, and that's why I didn't cover that part either. I didn't also cover the specific industrial and enterprise applications of fiber optic cables, and again, such as like how data center fiber optic cabling is different from that of the fiber optic cable that come into your house, for example. Again, to keep this lecture as short but still relevant to IT technicians. Remember, this course is targeting the IT technicians and people who are new to IT industry and those technical standards, not necessarily going into engineering of the fiber optic cable. So that's why I meant by and. So that would bring us to the end of this lecture. If you like these type of lectures, please make sure to thumbs up this video and subscribe to my channel. Until next time, thank you so much and have a nice day.